Good morning to all of you. Welcome back to Hospitality Engineering. Today we continue Energy Conservation and Energy Efficiency Module 12. Energy, Part 1. What we cover in this energy chapter. This section explains the issues associated with our use of energy and why we all need to be more efficient. It shows how you can assess current energy performance in your hotel, the measures you can take to conserve energy across various departments, and provides guidelines to help you when considering investment in new equipment. What is energy? Energy is found in a variety of forms, some of which are immediately useful, others require process of transformation. The sun is the primary energy source in our lives. Water, coal, petroleum products, nuclear power plants, etc. are sources of energy. Why to reduce energy consumption? There are overwhelming reasons why we all need to reduce our overall energy consumption and our dependence on energy derived from fossil fuels. These relate to what we now know about the causes of climate change and its potential global environmental and economic consequences, energy demand, security of supply, and the likely impact on costs in the future. Technologies, alternative fuels and techniques for mitigating greenhouse gas (GHG) emissions. Climate change. The evidence. Over the past 100 years, average global temperatures have risen by 0.7 degrees Celsius. The year 2005 was the hottest on record, 2006 was nearly as warm, and the last decade has seen the 8 hottest years ever recorded. Worldwide, glaciers and snowlines are retreating and prolonged droughts are on the increase, sea levels and temperatures are rising, and storms and hurricanes are becoming more frequent and severe. Scientists and climate experts agree almost universally that the climate changes we are experiencing now are being caused by human, anthropological, intervention and development, largely through emissions of greenhouse gases, GHGs. These include carbon dioxide, CO2, methane, CH, nitrous oxide, N2O, hydrofluorocarbons, HFCs, perfluorocarbons, PFCs, and sulfur hexafluoride, SF. GHGs are released by the burning of fossil fuels to meet demand for energy for power generation and transportation and through activities such as deforestation and agriculture. Carbon dioxide is regarded as the most serious contributor, particularly because its emissions are increasing significantly. Global CO2 emissions increased by 70% between 1970 and 2004. According to the Intergovernmental Panel on Climate Change, IPCC, the global atmospheric concentration of CO increased from 278 parts per million ppm in dry air before the Industrial Revolution to 384 ppm today, 21 far more than the natural range of 180 to 300 ppm observed in ice cores from the last 650,000 years. The situation is being made worse by the extent to which we have depleted the world's forests and woodlands that absorb atmospheric CO, and we are only just beginning to understand the role that the world's oceans play in the absorption of CO2. What if we don't act? Al Gore's film An Inconvenient Truth, released in 2006, forced millions of ordinary people to contemplate, many for the first time, the effects of man-made global warming, now and in the future. The same year Sir Nicholas Stern published his review on the economics of climate change, which set out the likely costs to tackle climate change issues in clear global economic terms. While it found that all countries will be affected by climate change, it is the poorest who will suffer earliest and most. The report claims that uncontrolled climate change could raise average temperatures by more than 5 degrees Celsius from pre-industrial levels, which would not only transform the physical geography of our planet, but would also have enormous consequences for all life upon it. It calculates that the cost of unabated climate change would amount to at least 5% of GDP each year and possibly 20% or more. In contrast, it argues that the cost of action to reduce GHG emissions to avoid the worst impacts of climate change could be limited to around 1% of global GDP each year. This could be achieved through measures such as carbon pricing through taxation, the expansion and linking together of emissions trading schemes around the world, government policies and international cooperation, particularly with developing countries, to encourage the development of low-carbon technologies in drought-resistant crops, and educating the global community about how each individual can respond to climate change. Finding solutions for climate change. Addressing our climate change problems necessitates a global policy response, guided by a common international understanding of the long-term goals for climate policy and strong frameworks for cooperation. Two kinds of measures are essential if we are to reverse the global warming trend. These are mitigation, reducing emissions, particularly in developing countries, or removing them from the atmosphere through sinks, and adaptation, including technology such as better flood defense and early warning systems, better risk management and insurance options. The Kyoto Protocol was adopted on December 11, 1997. Owing to a complex ratification process, it entered into force on February 16, 2005. Currently, there are 192 parties to the Kyoto Protocol. In short, the Kyoto Protocol operationalizes the United Nations Framework Convention on Climate Change by committing industrialized countries and economies in transition to limit and reduce greenhouse gases, GHG, emissions in accordance with agreed individual targets. The convention itself only asks those countries to adopt policies and measures on mitigation and to report periodically. The Kyoto Protocol is based on the principles and provisions of the convention and follows its annex-based structure. It only binds developed countries, and places a heavier burden on them under the principle of common but differentiated responsibility and respective capabilities, because it recognizes that they are largely responsible for the current high levels of GHG emissions in the atmosphere. In its Annex B, the Kyoto Protocol sets binding emission reduction targets for 37 industrialized countries and economies in transition and the European Union. Overall, these targets add up to an average 5% emission reduction compared to 1990 levels over the 5-year period 2008 to 2012, the first commitment period. In Doha, Qatar, on December 8, 2012, the Doha Amendment to the Kyoto Protocol was adopted for a second commitment period, starting in 2013 and lasting until 2020. As of October 28, 2020, 147 parties deposited their instrument of acceptance, therefore the threshold of 144 instruments of acceptance for entry into force of the Doha Amendment was achieved. The amendment entered into force on December 31, 2020. One important element of the Kyoto Protocol was the establishment of flexible market mechanisms, which are based on the trade of emissions permits. Under the protocol, countries must meet their targets primarily through national measures. However, the protocol also offers them an additional means to meet their targets by way of three market-based mechanisms. International Emissions Trading, Clean Development Mechanism, CDM, Joint Implementation, JI. These mechanisms ideally encourage GHG abatement to start where it is most cost-effective, for example, in the developing world. It does not matter where emissions are reduced, as long as they are removed from the atmosphere. This has the parallel benefits of stimulating green investment in developing countries and including the private sector in this endeavor to cut and hold steady GHG emissions at a safe level. It also makes leapfrogging, that is, the possibility of skipping the use of older, dirtier technology for newer, cleaner infrastructure and systems, with obvious longer-term benefits, more economical. The Kyoto Protocol also established a rigorous monitoring, review and verification system, as well as a compliance system to ensure transparency and hold parties to account. Under the protocol, countries' actual emissions have to be monitored and precise records have to be kept of the trades carried out. Global energy demand and supply. Demand. According to the International Energy Agency's World Energy Outlook 2007, if governments around the world continue with their existing policies, the world's energy needs will be well over 50% higher in 2030 than today. This poses a threat to energy security and oil prices and will accelerate climate change. China and India together would account for 45% of the increase in global primary energy demand, as both countries' energy use is set to more than double between 2005 and 2030. Fossil fuels, in the form of oil, gas and coal, continue to dominate the fuel mix, with coal set to grow most rapidly because of demand from the power generation sector in China and India. These trends will lead to continued growth in global energy-related. China is the largest emitter of carbon dioxide gas in the world, with 10,668 million metric tons emitted in 2020. The U.S. is the second largest emitter of CO2, with 4,713 million metric tons of total carbon dioxide emissions in 2020. India is the third largest CO2 emitter, with 2,442 million metric tons of total carbon dioxide emissions produced in 2020. Security of energy supply. Consuming countries will increasingly rely on imports of oil and gas, much of them coming from the Middle East and Russia. Although production capacity at new fields is expected to increase over the next 5 years, it is very uncertain whether it will be enough to compensate for the decline in output at existing fields and meet the projected increase in demand-supply problems in the period 10-2025 cannot be ruled out, which would lead to an abrupt escalation in oil prices. In addition, recent years have seen some countries pursuing isolationist or protectionist energy policies which could have severe consequences for the global economy and for global energy security over the longer term. Open, international markets and political stability are important factors in ensuring future security of supply. Technologies, alternative fuels and mitigation techniques. Energy efficiency. At both a global and local level, the cheapest and fastest way to curb demand and emissions growth in the near term is by improving our energy efficiency through investment in technology to improve efficiency and through financial mechanisms to support its take-up. For example, tougher efficiency standards for air conditioning systems and refrigerators in India and China alone would, according to the IEA, save the amount of power produced by the Three Gorges Dam in China by 2020. Emissions of local pollutants in both countries, including sulfur dioxide and nitrous oxides, would also be sharply reduced. Alternatives to fossil fuels. Nuclear power generation provides an alternative, albeit a controversial one, to the use of fossil fuels. Whilst not emission-free, it can make a valuable contribution to reduce emissions and meeting Kyoto Protocol targets. However, there are a number of problems, including the disposal of nuclear wastes which can remain radioactive for millions of years, the fact that the world's resources of uranium are finite, the possible health effects of living close to nuclear plants, and the potential consequences of accidents or terrorist attacks. Some countries, Austria for example, have renounced nuclear power altogether or, like Germany and Spain, are planning to phase it out. However, others such as France, the Ukraine and Finland are maintaining or expanding their nuclear energy capacity. Sustainable energy sourced from alternative, renewable sources such as the sun, wind, water and waves, biomass, geothermal, ethanol and biodiesel, can substantially reduce GHG emissions and those of other pollutants. Greater availability and take-up will increase the diversity of energy supplies and help to replace diminishing fossil fuel resources over the long term. The growth in demand for renewable energy such as wind power in industrialized countries is leading to economies of scale which will also make it increasingly accessible to the developing world. Governments can use various strategies to make renewable energy more competitive, particularly by removing trade and investment between countries with significant renewable resources. Mitigation techniques. For key climate change indicators, greenhouse gas concentrations, sea level rise, ocean heat and ocean acidification, set new records in 2021. This is yet another clear sign that human activities are causing planetary scale changes on land, in the ocean, and in the atmosphere, with dramatic and long-lasting ramifications. The key to tackling this crisis is to end our reliance on energy generated from fossil fuels, the main cause of climate change. The good news is that the lifeline is right in front of us, says UN Secretary-General Antonio Guterres, stressing that renewable energy technologies like wind and solar already exist today, and in most cases, are cheaper than coal and other fossil fuels. We now need to put them to work, urgently, at scale and speed. The Secretary-General outlines 5 critical actions the world needs to prioritize now to transform our energy systems and speed up the shift to renewable energy. Without renewables, there can be no future. Your hotel energy management program. An effective energy management program will help to maintain the profitability of your hotel and should not have an adverse impact upon the comfort or satisfaction of your guests. Objectives. In striving to become more energy efficient, your aim will be to provide a comfortable internal environment. The aim is to create an energy efficient, comfortable internal environment for guests and staff by cutting waste, not corners. This will help you retain your customer base whilst reducing your costs and your carbon footprint at the same time. Improve efficiency. This requires operators to understand, operate, and maintain the hotel's energy-consuming equipment and systems in an energy-efficient manner. Efficient buildings, equipment and systems that consume less energy and cheaper energy to accomplish their task. Energy management is a continuous learning process. There are often enhancements you can make to improve the efficiency of your equipment, and the way that you operate it. Regular efficiency measurements should become a standard procedure for major energy consumers such as boilers, chillers, cooling towers, and air handling units. Adjust to changes in loads. Resources should be adjusted according to the time of day, day of the week, season, occupancy, and weather. This will create tremendous potential for savings. Operate profit, cost centers. Those who use the energy must be accountable for it. You will need to install sub-meters and allocate charges to each department according to their consumption. Any independent operators on the hotel's premises should also be recharged for the energy they use. Use performance criteria. You will need to develop and use performance criteria for each department, set targets, and continuously monitor results. Invest in new technology. You should constantly review available technology and assess whether it can help create efficiencies within your own hotel operation. Set high standards for new projects. When planning refurbishment, extensions, or new buildings, it is important that the building is designed for optimum energy efficiency. Check that the lighting, heating, cooling, and total load requirements in kilowatt-hour per square meter comply with state-of-the-art efficiency levels. You must also ensure that the building's mechanical, electrical, and plumbing systems are properly commissioned and in perfect working order. Make sure you obtain complete test certificates, balancing reports, and completion checklists, as unresolved problems and unsatisfactory work can result in higher energy costs and lower standards of guest and staff comfort for the rest of the building's life. Avoid superfluous and wasteful devices. For example, avoid purchasing fashionable outdoor bottled gas, LPG, heaters, as they use significant amounts of fuel and much of the heat is quickly lost to the surrounding environment. Provide adequate training. Good training may be the best investment you ever make. If your staff believe that they are playing a key role in your energy achievements and making a positive contribution to the local and global environment, it will help build morale. Empower your staff to take decisions by making sure they have the necessary training and knowledge to fulfill their role successfully. This will increase their confidence and job satisfaction, reduce period of absence, and will be reflected in their interaction with each other and with your guests. Let us see breakdown of typical utility costs for hotels. Electricity 50%. Steam or hot water 28%. Fuel 5%. Gas and kitchen consumption 7%. Water 10%. Typical energy audit by cost. HVAC 22%. Guest rooms 19%. Kitchens 12%. Laundry 8%. Swimming pool 8%. Lifts 8%. F&B venues 6%. Lockers and public area 14%. Others or non-metered area 2% to 3%. Energy Saving Action Plan. Monitoring. Monitoring is the regular checking of consumption levels by establishing routines for reading utility meters and enables you to check the accuracy of your energy bills. By monitoring at regular intervals, unexpected changes in consumption, perhaps due to the faulty operation of equipment, leaks, poorly set controls, or other sources of waste, can be detected rapidly and corrective actions taken. Regular monitoring also provides a flow of detailed and comprehensive operating information, which is a vital component of good management. Ideally, you will have installed a system of sub-meters serving different areas or departments of the hotel. Reading these submeters on a regular basis, daily or weekly, will help in diagnosing where and why any unexpected consumption occurs. It will also enable you to recharge energy costs both internally to cost center within the hotel and to any independent operators who may be using the hotel premises, such as a shop or hair salon. This will place accountability for energy costs on those who are responsible for usage and will give them a financial incentive to ensure that energy is not wasted. Meter readings can be taken manually or may be automated. If you record your meter readings on a simple computer spreadsheet, it will help to simplify the process of calculating consumption, enable a variety of analyses to be performed, and allow you to display the results as graphs or charts, so they can be readily understood by others and become a part of your energy efficiency communication campaign. Targeting. Targeting is the process of setting targets in order to provide an incentive for reducing waste. In an individual hotel, target consumption figures are generally set with reference to historical consumption levels. If the hotel has been extended, altered, refurbished or has had new facilities added, your targets will need to reflect the anticipated impact of these changes. Correction factors also need to be applied to account for any significant alterations in occupancy and weather conditions. In a hotel chain or group, targets may be set by reference to the best performer, or more realistically, the worst performers may be compared with the average. Where industry norms are available, these may be used as target values. See, for example, the tables for guest rooms, kitchen, and laundry. An alternative, but less common way to set targets is to develop them with reference to theoretical calculations, such as how much heat the building gains and losses, or how much electricity is required for the lighting system to achieve a given level of illumination. Targets need careful consideration, and realistic target and then actually achieving it will provide positive motivation for staff to continue making progress. If the existing energy efficiency of the premises is very poor, it may be possible to achieve a 10% or more improvement in the first year through initial one-off changes. However, it is unlikely you will be able to sustainable this over time, and you should be wary of setting the goals too high. An annual energy reduction of 25% of current consumption is typical, and can usually be achieved through good management and care. Annual savings of about 5% or more may be achievable with good managerial and financial support. Excessively onerous targets may well be dismissed by staff as being unachievable and could undermine your program. Remember that wasteful habits can become ingrained, and staff may need to have regular refresher training sessions if good practices are to continue. Monitoring and targeting systems. In its simplest form, monitoring and targeting can be performed manually. This involves reading meters regularly, establishing consumption targets, comparing actual consumption against targets, and taking corrective action where necessary. Computer-based MNT systems can read meters and submeters automatically, including those at remote sites, undertake various statistical analyses of the readings, and produce regular management reports. It should be remembered, however, that if MNT systems are to be implemented successfully and their potential benefits achieved, it is essential that operators understand the system fully, rather than relying on outside consultants. Input consumption data is reliable, and not incomplete or late. Outputs are displayed in various graphic formats, not just columns of numbers, which are comprehensible to senior managers, energy managers, and staff. Reduction targets are realistic, rather than arbitrary, with no adjustments for changes in equipment, etc. Excess energy use is flagged quickly and investigated rapidly by appropriate staff. Monitoring, targeting, and contract energy management. It may be appropriate to employ consultants to identify energy conservation measures for your hotel. Typically, they carry out a site survey and identify no-cost, low-cost, and capital expenditure measures which will save energy. These will be accompanied by recommendations for training requirements, a schedule for maintenance and future equipment replacement, recommendations for refurbishment, and a summary of the anticipated benefits from implementing these measures. No-cost measures are implemented first, with the consultant advising on appropriate training to improve staff awareness, providing expert guidance and advice, and agreeing targets with you. When low-cost and capital projects are implemented, targets should be revised to reflect the expected savings in energy. The consultant may also advise on utility rates and seek rebates from utility suppliers in cases of overcharging. Consultants should be made responsible for monitoring and comparing consumption against targets, and should provide you with information so that you can assess their effectiveness and performance. Ensure that the data is passed to you and remains yours. If you plan to enter into a partnership agreement with expert energy consultants, make sure that your hotel's current performance is as good as it can be before you start. It is also important to consider the basis under which their fees are set. If your consultants are to be paid a percentage of the savings achieved, there is a risk that they may identify and correct an area of inefficiency but continue to gain the benefit for several years afterwards. The conditions of engagement should be set up so that they are fair to both parties. Consultants may be paid an agreed percentage of the savings they achieve, but if they are involved in obtaining utility rebates, a one-off fee for this aspect may be more appropriate. Ensure that performance, target setting, and remuneration are reviewed annually. Let us see a typical fuel and steam consumption calculation for any hotel. Use following constant. Natural gas, for cooking, 9.3 kilowatt-hours per liter. Light fuel oil, boilers, 8.3 kilowatt-hours per liter. If district hot water, steam, 278 kilowatt-hours per GJ. Now you can substitute consumptions and add all consumption together to get total kWh as consumption. Let us see an example step by step here. Step 1. Add up your electricity kilowatt-hour consumption for the past year, for example past 12-month electricity consumption. Step 2. Work out the usable space of your hotel. Note, exclude outside areas, storage areas, and garage space, unless significant appliances are being used there. Step 3. Divide your past year's electricity use by your square meter space. Example. Next step, total consumption in kilowatt-hour divide by total floor area in square meter. Now you will get consumption per square meter in kilowatt-hour per square meter per year. We see here a fully serviced 4- or 5-star luxury hotel profile. 150 to 1,000 rooms. Air conditioning and heating. Average of 55 to 100 square meter per room, 60% of total hotel area dedicated to guest bedrooms. Laundry producing 6 kilograms per laundry per occupied room per day. Health suite and pool of up to 150 square meter surface area. Year-round opening, operating at 70% occupancy. Gardens of up to 1,000 square meters. 1 employee per room. Benchmark for electricity and others hotels. Case 1, luxury serviced hotels. There are 3 climate zones like temperate, Mediterranean, and tropical. Here energy consumption kilowatt-hour/square meter tabulated as excellent, satisfactory, and high based on consumption pattern. Here for ready reference benchmarking modifiers for electricity with 3 climate zone constant provided. Here for ready reference benchmarking modifiers for others constant provided. You can see here benchmarking modifiers for heating energy for ready reference. What is the meaning of heating degree days? Heating degree days, HDD, are a measure of how cold the temperature was on a given day or during a period of days. For example, a day with a mean temperature of 40 degrees Fahrenheit has 25 HDD. A simple illustration is provided for your better understanding. What is the meaning of cooling degree days? Cooling degree days, CDD, are a measure of how hot the temperature was on a given day or during a period of days. A day with a mean temperature of 80 degrees Fahrenheit has 15 CDD. If the next day has a mean temperature of 83 degrees Fahrenheit, it has 18 CDD. The total CDD for the 2 days is 33 CDD. Submetering and its advantages. Separately installed meters downstream of the main meters that measure individual consumption of equipments. Advantages: conduct accurate energy audits, true efficiency, better control, reliable information, determine feasibility of capital investments, enhance management accountability, immediate feedback on results. We stop here now on Energy Part 1, which has further one more part. Thank you for watching. Like and share this video and subscribe to our channel for more training contents. Thank you.